Hey friends of the Marcus Performing Arts Center, thanks again for joining us here at the Mad Science Laboratory. Dr. Coco here. We have a whole bunch of weather experiments that we would like to share with you today. Weather is something that affects every single one of us, and the study of that phenomenon is something that we call meteorology. Today, I'd like to show you a couple of experiments that explore the forces and phenomena that cause the weather to be the way that it is around us, as well as show you some of the tools that meteorologists use to study the weather that you can build and add into your very own weather station. I'm very excited to share these experiments with you, and I hope you enjoy. One of the things that is noticed the most about weather is wind. Wind is a result of just different pockets of the Earth's atmosphere moving and shifting their positions as they change their heat and density. And there's a lot of different things that can dictate how dense a pocket of air can be, between its temperature, how much moisture is mixed in with the air, as well as other different particles that can be added to it. Now, there's a great way that you can study how different currents of the atmosphere move around by making what we call the colorful convection experiment. And what we're going to be doing is essentially creating a convection current. You see, whenever you have a bunch of really cold air and a bunch of really hot air, the cold air is going to be much denser than the hot air. That hot air is going to want to rise up above the cold, denser air, which is going to want to sink down below. And as those two parts of the atmosphere change positions, they create the wind as we feel the air being moved by all the air around it. In order to do this experiment, you only need to find a couple of things in your house. First and foremost, you're going to need a big clear container that you can put a bunch of water in. I have a big old plastic fishbowl here that I'm using for this. You're also going to need to find, I recommend, red and blue food coloring, as well as an ice cube tray as well. Now, the first step to this is you're going to want to color some water blue and then put it in your ice tray and let it freeze overnight. So I have some really nice blue colored ice cubes like I have right here. Now, these ice cubes are incredibly cold and super dense compared with the water that's around it. Now, surprisingly, this ice is going to float once it sits in the water because ice does actually expand, making it less dense than the water around it. But as this ice cube melts, it's going to chill the water that's immediately around it, making that water much denser. Once you have a couple of your blue ice cubes, drop them right into your large container on one side. And they're going to start immediately melting and affecting the water that's around it, chilling that water, making it become more dense and heavier, and it should start to sink. Now, to help out with this, you can always add a couple of extra drops of blue food coloring right above the ice cubes. And as you can see, the heavy cold water sinks down to the bottom. Now, as this cold water is sinking down to the bottom, it's going to actually be pushing the warmer water that's in the fishbowl to start with up in the other direction. Now, you can see that by putting just a little bit of red food coloring on the other side of your container. And as you watch, you're going to see the cold water sink down on one side, sink along the whole bottom, and then push up the red water, which should start traveling and settling among the top of your container. This is going to take a couple of minutes to do, so it is a really nice kind of picture. You just kind of sit and watch, but over the course of a couple of minutes, you're going to see how the different currents, how the cold, denser water is going to sink down and push the hot, lighter water up to the top, and it's going to create almost a swirling motion. What you're observing is a convection current. Now, this convection current doesn't just happen in the atmosphere. It happens in the water. It happens in the liquid magma inside of our plate tectonics, inside of our own planet, all the way out into the burning furnace inside of most stars. Anytime that you have some sort of fluid, you're going to see this type of behavior. It's a really cool experiment, and I hope you enjoy watching how this natural phenomenon plays out right before your eyes. Ooh. Let's see. Hot is on the top, cold is on the bottom. Hey scientists, if you've ever looked at a weather station, you've probably seen something like this sitting on the top of it. It's a special tool called an anemometer, and we use it to measure wind speed. Essentially, we can count how many times that this little tool will spin around, and it gives us an idea of how fast the air is traveling through it. Now, if you want to make your own anemometer, to make your own weather station, there's a very easy way that you can put it together. And you're only going to need to find a couple things around your house. First off, you're going to want to find a couple of small paper cups like this. I've also seen people use plastic cups. Those work just as well. You're also going to need to find a couple of lengths of straw that you can cut to be the exact same size. And also I recommend finding a toothpick and one of these little thin coffee stir straws as well. Once you find all of these parts, also make sure that you ask for an adult's help in putting this build together, as they are going to have to help you using a thumbtack and preferably paper hole punch as well. Now, the way to put this together is a couple of step process that I'd like to walk you through. Now, first off, you're going to need to make a base for the anemometer, something that's going to hold all of the arms that are going to hold each of the individual cups when everything is said and done. In order to do that, you're going to want to take one of your cups and you're going to want to punch holes on the outside rim opposite each other all the way around. 4 holes should do it. So one punch there and then one punch right on the other side, exactly opposite that hole. And then do the same thing again, like east and west, if you're going to be looking at the cup from up top. So as you can see, I have 1, 2, 3, and 4 holes all around the outside of the cup, opposite from each other. Now, the next step is where you're going to need help from an adult. I would like to recommend that you take 2 straws and ask an adult helper to take a push pin or thumbtack and punch a very small hole right through both straws, right in the middle of it. Now you can do this either very carefully, one at a time, or you can try to punch a hole through both of them at once. Once you have both of your straws punctured with a nice little hole right in the middle, you can get rid of the thumbtack. That's the only time that you're going to use that. The next step is to take your straw and thread it through those holes you just punched, so that the hole in the middle of the straw is right in the middle of the cup. Do that with both straws so that the straws cross over each other and that little teeny hole in the middle lines up on both straws. Now, to hold these straws in place, take your toothpick and stick it through all of the holes in the straw. And this may take a little bit of finagling to actually do, so you have to be patient with this part. But what you're going to do is essentially hold these arms in place. Then you will be ready for the next step. Yeah, just like that. Okay, once your straws are attached to the toothpick, which, hold on for 1 second. Let me get this on there just right. Once you have both of the straws attached to your toothpick, the next step is going to be to take your other 4 cups and tape them to the outside of each of these ends of the straw that are sticking out your cup. Now, there's 2 different ways you can do this. I recommend just finding a little bit of clear Scotch tape like this and using that way. And the trick to this is you want to make sure that all the cups are facing the same way as you go around the outside of your anemometer. This is going to make sure that as the wind travels past it, it's going to be caught in every single one of the cups, helping spin your anemometer around at a regular speed. Once you have all of your cups lined in the same way, you can go ahead and take a little bit of tape and just tape the cups so that they stay on the straws. Now, another quick tip, if you want to really make an official anemometer, one of the cups should be colored a different color than the rest of them. That way, you'll be able to count how many times that one cup makes a full circle around the rest of the cups. And it'll help you actually gauge the speed of how the wind is moving forward. Once you have all of your cups taped to the straws, then all you need left to do is rest this on a nice little podium or something that will help it spin. That's what the little coffee stir is for. Let me get this last cup right on here, just like that. Now, all you have to do is you should have a bunch of toothpicks sticking out the end. You can slide that right into the middle of your coffee stir stick, and your anemometer should be able to spin freely. And when you put it up into the wind, you should be able to gauge, at least somewhat reasonably, how fast the weather is going. Now, if you excuse me, I've got to make sure that I have my counting cup marked. I'm just going to make one big red dot right on the end there. And now, I can see how fast the air from this hairdryer is going. This is a really fun way to build your own weather station, scientists. I hope you enjoy this build and keep exploring the world around you. Now, this build does take a couple of steps. So, let's take a close look so you can see every single thing that you're going to need to do to build this anemometer. Another tool that you find in a lot of weather stations is called a barometer. A barometer is something that helps us measure the difference in the air pressure that is affecting the area that we're in. Very much like how a thermometer tells us a difference in temperature, a barometer helps us tell the difference in air pressure. You can make your own barometer at home using just a couple of you can make this at home using just a couple of pieces of equipment that you'll find laying around your house. In order to make your very own barometer, the first thing you're going to need is a big bowl that you can fill with some water, a clear bottle, I recommend some blue food coloring, and a Sharpie. Or any other type of permanent marker. I also recommend finding some sort of index card, as that will be very helpful for putting everything together. Now what we're going to do is we're going to take this bottle and we're going to fill it with water almost to the top. We're going to leave a little bubble of air right, and let's see, maybe, yeah, we're going to leave a little bit of a bubble there, about that much of the bottle left. Now, to help us see how this water is moving a little bit easier, we can color this water with a little bit of blue food coloring. Now, the next step, once you have this, is you're going to have to cover your bottle and slowly, carefully tip the whole thing over and then submerge the bottle in the bowl of water right in front of you. Now, as you can see, we have a whole lot of water that's suspended inside of this bottle itself, and we have a little bubble of air that's sitting on the very top. Now, this bubble of air inside is what we call a constant. It's not going to change its pressure very much as the day goes by. However, all of the air outside of this bottle is going to change as the weather changes around us. You see, the higher air pressure that you're around, the most likely you're going to see clear skies. Lower air pressure is going to give us cloudy skies. And what we've done here is give us a way that we can measure the changes in that air pressure. The more air pressure is outside this bottle, the more air is going to be pushing down on the water in the bowl. That water is actually going to be able to compress and squeeze this little air bubble in the top. And as we have a higher air pressure inside or outside the bottle, it's actually going to squeeze this bubble and raise the air or the water level up. Now, once you have your barometer set, you can take a marker and just kind of mark where the water line is to start with, and then wait for the weather to change. If all of a sudden you are sitting in a cloudy sky day when you make your first mark and then it clears up after a while, go back and check your barometer again. Most likely, the water level will have changed. In fact, you'll probably be experiencing a high pressure system with clear skies, which means that you can expect your water level and your barometer to be a little bit higher than the mark that you put on before. If you were sitting and made your first mark during clear skies and all of a sudden it turns cloudy or stormy outside, take a look at your barometer again, and most likely that lower pressure will have actually caused the water in your bottle to lower itself a little bit below where the original line was. Keep on checking your barometer over the next couple of days and mark off whenever you see the water line change. And after a little while, you'll have a real nice gauge of knowing, just by looking at this bottle, what the weather outside is going to be like. Enjoy this build and enjoy learning more about meteorology, everybody. It's a really fun tool. Yep, it's going to be cloudy outside. Traditionally, in meteorology, they say that high pressure systems lead to clear skies and low pressure systems lead to cloudy skies. But have you ever wondered why? It has to do with how much moisture the air molecules can absorb, and that is dictated specifically by how much pressure that air is under. Now, we can recreate this effect by making what's known as a cloud in the bottle. It's a really fun, classic experiment that I've always had a lot of fun doing. In order to do this experiment, the first thing you're going to need is a clear plastic bottle that has a nice sealable top on the top of it. You're also going to need a little bit of water and an adult with some matches. And again, everyone, safety warning, this is technically a fire experiment, so make sure that you have an adult with you when you try this, especially because it's very cool and they'll want to watch it as well. Now, in order to do this experiment, the first thing you're going to have to do is put a little bit of moisture into our atmosphere, essentially the air inside this bottle. So I'm going to pour just a little bit of water into this bottle, not very much, just a little splash. And then I'm going to seal it up and give it a really good shake. Now, what I'm doing is I'm actually evaporating a lot of the water and having it mix with the air inside this bottle. Now, not all the water that I poured in here is going to be able to be absorbed by the air that's inside of there, but we can get a good amount of moisture inside. Now, I'm going to pour the rest of the air out, or the rest of the water out. And then I'm going to add a little bit of smoke to our atmosphere. Smoke is made up of very, very small particles, and those particles will allow all of the different droplets of moisture that have been absorbed in this air to cling to something when the pressure changes. Now, this is the fire part, so make sure that you have an adult to help you. And all you need to do is put a little bit of an extinguished match smoke into the bottle itself. Now, I recommend first off making sure the lid is off your bottle. And then just let some of the smoke from the match go inside of the bottle, just like that. Once you have that, you can go ahead and seal it up very, very quickly to make sure that nothing gets lost, and give it another good shake just for good measure. And if you look inside, you shouldn't see too much happening inside the bottle right now. That's because right now it's under constant pressure. But if we add extra energy to our atmosphere by giving the bottle a really good squeeze, we're adding more energy to the air molecules. That extra energy is going to allow the air molecules to absorb more moisture, essentially making it even clearer inside than it was before. Now, the next thing we're going to do is release that pressure, essentially just let go of the bottle. When the bottle expands, it's going to create a much larger area for the air to fill inside. And that air is going to become less dense. It's going to have less pressure around it. And that is going to allow it to not be able to absorb as much moisture. And when you let go, you get a little bit of a cloud that forms inside the bottle. Now, it may be kind of difficult for you to see it in my camera here. And that's because it is kind of a faint mist inside the bottle. But air and water aren't the only two things that you can mix together for this experiment. I want to show you another version of it using isopropyl alcohol. Now, I would recommend that no one try this experiment at home, as isopropyl alcohol is a volatile chemical and needs to be handled very, very carefully. But isopropyl alcohol is a much smaller molecule than water itself, which means that air can absorb it much, much easier. I'm going to put a little bit of this into this bottle and again, shake it up just like I did before and try to see if I can't get a lot of that isopropyl alcohol to be absorbed by the air inside of this bottle. I'm going to pour out the rest of it and then I'm going to create a very, very strong high pressure system by pumping it with a whole bunch of air. Now, I'm going to be using an electric air pump for this and it's going to make a little bit of noise. But as this air continues to fill up the bottle, we're increasing the air pressure inside. As that air pressure increases, more and more of that isopropyl alcohol is going to be absorbed by the air around it, until finally that pressure has to be released, and when it does, we have a very, very cool cloud in a bottle. Now you can try this experiment at home like I showed you with a little bit of water and you'll get a similar result, but next time you look up at the sky, every single time you see a cloud, realize that you're looking at a little pocket of low pressure system allowing you to see all the little drops of moisture that are in the air forming together to make a cloud. It's another cool way of exploring meteorology, and it's a wonderful way to understand the world around you. I hope you enjoy these experiments, scientists. Until next time, happy science.